All right, so at this point, here are the answers. I also have this posted, so you should be able to just look at the key and get the answers. But as we're working through this, if f of x equals 0, then where should the graph of the function be located in relation to the x-axis? Well, this is something that we already know. We've done this with every single function we've dealt with, and it's no different with polynomial functions. So we know that when f of x equals 0, that means that y equals 0. So the graph should be on the x-axis. Whoops, let me spell that correctly. On the x-axis. And that is because this is where y equals 0, because f of x is y. So when f of x equals 0, or when the function is equal to 0, graphically, we're looking for where the graph is on the x-axis. Okay? So that's a connection. That's a big connection. We already actually know that. Okay? So zeros are where f of x equals 0. Okay? Look on the x-axis. So the zeros of the graph, okay? The y-intercept of the graph is the constant term. So there's the connection. And then that thing that I talked to you about at the beginning, it's called multiplicities, okay? But a factor that shows up once the graph goes through the x-axis at that value. If a factor shows up twice, the graph, we're going to say bounces off the x-axis at that x value, where it turns around. Okay. So here's two graphs, and we're going to use the graphs to answer the questions. Okay. So it says to write the equation of f of x in factored form. Okay, fantastic. We know that this graph has 3 zeros, and we know the zeros are connected to the factors. So we know x equals -2 is one of them, x equals +1, and x equals +2. If we're going to change those into factors, then all we are literally doing is moving this over here so it equals 0. So that means our factors are x plus 2, x minus 1, and x minus 2. Okay? And we'll call that f of x. Let me start it off with f of x. So f of x equals x plus 2, x minus 1, and x minus 2. Then it wants us to write that equation in standard form. Fantastic. We're just going to multiply that sucker out. So f of x equals, when I multiply the first two together, I get x squared plus x minus 2 times x minus 2. And then keep going. I'm going to distribute x squared to these two. So I get x cubed minus 2x squared plus x squared minus 2x minus 2x plus 4. Okay. And then I combine my like terms, x cubed minus x squared minus 4x plus 4. This standard form makes sense because the constant is 4, and the y-intercept is also 4. Also, there are 3 factors, and it's a third-degree polynomial, so either of those reasons would work great. Okay, let's do the next one. This one has 2 zeros that we can see, x equals -5 and x equals -1. But this one right here is a double root because the graph hits that 0 and bounces off. So that means that this factor counts twice. It shows up twice. All right, so this is going to be g of x. So my factors are going to be x plus 5 and x plus 1, and that x plus 1 shows up twice, okay? So if we write this in standard form, we get x squared plus 6x plus 5 times x plus 1. That's x cubed plus x squared plus 6x squared plus 6x plus 5x plus 5. So g of x equals x cubed plus 5x squared plus 11x plus 5. Did I do that right? That should not be minus x squared. That should be plus x squared. Let me back up. So that makes this 7x squared. All right, and then one reason that this makes sense is because the y-intercept is 0, 5, and our constant in the equation is also 5. All right, that's it for this lesson. I hope that it makes sense. It's just practicing that factoring and seeing what the connection is between the equation and the graph so that we can work both ways.